Welcome. I am Hubert, developer advocate at StarTree. If you don't know, this is a meetup, and the meetup is about consuming Wikipedia page changes into Kafka and ultimately into Apache Pinot, and then we're going to view some of that data in a Jupyter notebook. So this is the pipeline. We're going to have a Python application that's consuming some changes from Wikipedia. We're going to send that to Kafka and then into Pinot, and then we'll look at that data in Jupyter Notebook. This isn't your regular. I mean, it looks pretty simple. This diagram here, this pipeline to the Jupyter Notebook, it looks pretty simple. But I've changed this a little bit around so that we could see more real issues that we would run into when we're building a real-time analytical pipeline. First of all, the Python the Python application isn't using a server-side event. So if you're not familiar with server-side events, there are they're almost like streaming clients where you can consume events that are changes. They're very asynchronous approach, right? I'm actually instead consuming an RSS feed. So if you look at this, I'll show you an example of what that looks like. This is the actual endpoint that I'm consuming, and I'm reading and parsing and understanding what changes that have been made to on Wikipedia. I'm doing this because you could get duplicates, right? So if I refresh this, I might get the same answers. It may change in a couple of seconds, maybe not. But I'm polling this every so often, right? So I'm going to get changes. So what that means to me is that I'm going to need to handle that data in somewhere, either in my Python client, which I'm not, in some stream processor, maybe Flink, but there's no Flink here. So I'm most likely handling it in Apache Pinot. Right. So anything Apache Kafka obviously is a publish and subscribe streaming platform. You don't know what you're going to get. Some other clients that are consuming the same data may need some of that duplicate data, or for whatever reason. You need to be able to handle some of that data because it may not be exactly the way you need it to be. Okay, so that's one caveat we're going to kind of explore here a little bit. The sample document looks like this. It is in XML, but when I consume it, it's going to be in JSON. I'm using a Python library to just consume the RSS feed, and then it gives me this object. This object kind of looks like this, right? So, and this is a very kind of painful looking object. So, kind of easy way to handle this data schemas are, in my opinion, they're a huge pain, right? You have to build a schema from one place, then you got to replicate that schema to another place, and different syntax and so on. It's a huge pain. So there is a tool that the Pinot distribution gives you, which infers the schema, right? So what you could do is actually download this tool here. You can, by the way, I should have started off with this. Everything you're going to see here is in the GitHub repository. It's under StarTree data examples. And this one, if you look in here, the root page, the README, gives you a little bit of an intro what Apache Pinot and what the goal is with this repository. And then as we move forward, with each meetup or video we create, we're going to append to the bottom, or actually put to the top the latest changes. So actually at the bottom right here. This is where we are. And then back to the Python. Let's just go take a look at that really quickly. It's pretty straightforward, especially if you know a little bit of Kafka programming as a client. This is the feeder. This reads the feed. It gives me entries that are in JSON or in this like a dictionary format in Python, and I iterate through those, and then I send them to a Kafka producer. I'm using a Confluent Kafka producer, and I'm running everything locally in a Docker Compose, so I have access to everything. Okay, and there's nothing really crazy about this. It's all just reading, parsing the CSV or the RSS, and sending every entry in it to Kafka. So it is up to us in Pinot to handle that data. So how do we do that? Let's first generate a schema, because this is kind of a neat thing to do. Because I hate running schemas, and I have to kind of build my schemas myself. Um, all you do is grab this. What it does is going to grab a Docker Compose, so it's going to run it locally. So you need Docker, and you're going to um, write that data out. So I already have it here, actually. I know we don't. Let me just run that then. So here it is. Actually, I want to move this out of here because I don't want it. I don't want to. I don't want to. I don't want to commit that back to the repository. The way you run that is you create a config directory. So I'll do that. And then this is how you run it. You run Docker, and then you give it the sample JSON, which is the thing above that I pasted up here. So you can just copy that. And a directory that you would like to run this in. Okay. And this is the sample JSON. It'll put the schema. What this is going to do when it infers the schema, it creates you a Pinot schema so that you could build your tables in Pinot. So let's do that now. Actually, I'm going to go back into examples in Wikipedia because my data is in there, my sample. Just copy this. And this will generate a sample schema. So notice it only created the fields, right? It's not going to do anything else to the schema. And as you know, if you want kind of a good representation of your schema, you have to add other things to it, and I'll show you that now. You need to identify the timestamp because Pinot partitions this data on segments, using segments over time. So you need to tell a little bit about what kind of data you're receiving. And in this case, we're going to identify that this published, we're actually going to add a field called published milliseconds as the time field. And what we're going to do is we're going to parse some of the fields inside the RSS and build this timestamp field for Pinot to use for these segments. And we're also we're going to identify a primary key. In this document, there is an ID. This is the ID. And that's what we're going to use as the primary key. So why am I doing that? It's what we're going to do to get rid of these duplicates, right? Yeah, not even duplicates. They may or may not be duplicates. They could have one small change in them. We don't know. What we want to do is implement upsert into Apache Pinot. What this will do is when I query this data, I'm only going to get the latest record, right? The history is still preserved for each and every update for that ID, but when I query it, I'm going to get the latest record. So you do have both, the best of both worlds when using upsert. The final schema can be seen here. This is the inferred schema using Pinot's infer tool, right? Actually, this one. And then we added the date time field specs and then the primary key. So we just a couple of fields because there's no way when you're inferring a schema that any schema generating thing is going to know what your timestamp and your ID is going to be. You'd have to have your entire data set to be able to figure those things out. So it does a lot for you just because it does the hard part, right? You just need to add these parts to it. So that's the schema. So when you create a table in Pinot, you need two things. You need a schema, which we just created, and a table config. All right. So this table config is a bit hairy. It's not really that hard. And I'll walk you through this a little bit so that you can kind of understand it. First of all, we need to name the table the same name as the schema. So this is our schema here. The name of our schema is called Wiki. So we're going to name the table name the same thing. And then we're going to do a real-time table. There are two types of tables. In Pinot, there is a real-time table, and then there's an offline table. Okay, if you think of the Lambda architecture, right? You have your streaming data, and then you have your batch data, typically ending up in a lake house or data lake or of some data warehouse of some sort. You want to merge those two together, and this is where you do it. Pinot allows you to merge both of those datas into a single view so that you can query it with a single query with a Pinot does the merging together. You don't have to do that anymore. It makes the Lambda architecture really, really easy. And before you had to do that merge yourself, and that was a really hard task to do. But in this case, we're doing just real time. What that means is any real time table reads from a streaming platform like a Kafka or a Kinesis, right? Or a Red Panda. Real time, these are really unique tables in that there's a little bit of the data in memory so that it's able to query that data in real time. So there's very, very low latency. Okay. They're different than offline tables that tend to get updated from batch processes. And the last part of this really that we really need to worry about is the segment config. If you notice, if you recall the timestamp that we added to the schema, this is what is the schema config here is consuming that published milliseconds, and it's going to use that to build segments for the table. Okay, and then we're going to identify a little bit more. Here we're going to configure an ingestion configuration. So we are using still the published milliseconds, but we're going to parse a field in the JSON that is called published. And then this is the format, and that we want it to be converted into millis and using this column. So there is a little bit of a some ingestion transformation. So we're doing two things here, right? At ingestion, we're transforming the timestamp so that it makes sense to Pinot and to downstream consumers, because a lot of the BI tools like Superset really need an easy way to identify and handle time, and milliseconds tend to be that. If they have to parse it themselves, and you have to kind of preserve, or it has to be in a format that they understand. Keeping it in milliseconds really is the best thing to do, is just to keep it all. That was it. All tools understand milliseconds. I don't think that's really necessary here. That's no information. So we're transforming that data and putting it into milliseconds. Next thing we're going to do is add this section to the table config. This is what enables upserts. We're telling Pinot that this table is an upsert table, and there's a couple modes that you can set it to. There's a full and partial. Full means that I update all of the fields in the record, and partial, where I'm only updating certain columns in the record, right? Here we're doing partial, and then there are other options here to put in here. So these are the fields and the message that we're going to, in this case, overwrite. There are others you could do. Here's some more strategies. You can use increment it. You can ignore it. You could do a union. So there's a lot of things you could do with this upsert capabilities. We're just going to overwrite it because that's the traditional or the standard way of doing upsert. Okay, and that's all we really needed to know. This basically covers the entire JSON configuration. So it's really not that crazy if you think about it. These are all things that we should be able to understand and know. Okay. So now that we have a table configuration and a schema, let's create that. So let's look at Apache Pinot, by the way. This is the Pinot console. Here where your tables exist. Notice I already have a bunch of real-time tables existing. So if you go back to our repository, the way when you start up Pinot, it comes with a bunch of quick start applications. If you run this, when you download and install Pinot, there is a command line tool called Pinot Admin. It does all the work for you. You can start your broker, you can start your servers, etc. Here you can start a quick start where it's just a small version of what a small footprint Apache Pinot to run. And it also will run a bunch of install a bunch of like samples in it. If you just put this flag here and put stream, it'll add a bunch of real-time tables here that's consuming from kind of a mocked version of a Kafka internally. But we're going to put a real table in here and we're going to have it read from a real Kafka that's running right now. So I have both Pinot Kafka running. So if I do this, you can see a list of topics. I should have already a topic here that I created earlier. Okay. I have some other topics there that's going to be unrelated to this demonstration. So I don't need to create that. I do have a Pinot table that I would like to upload. And the way I'm going to do that is using that same Pinot command add table, where we give it the table config, which is the one we just created, and the schema. And then we always flag it with an exec. Otherwise, it's just going to check to validate the command is correct. Okay, so let's copy that, put that into our command, and that should create a table successfully added down here. Let me scroll this up a little bit. Okay, let's look at Pinot. Just refresh that. You'll see that there's a real-time wiki table, and here's our table config. Here is our schema, and we have a first segment. There may be a little bit of data in that topic from the last time I ran this. Let's go take a look to see if there is any data in it. So we go to our query console. This is where you can query Pinot. And yes, there's already 100,000 records in there. No matter, I'm gonna send more into there. So we could do that by using this command right here. This is our client and our Python client that's consuming the RSS feed. So let's do that there. So that's running in the background. And we can now start to do fancy, really hard questions. So let's do a simple query. Okay, we're going to query the last week. So this is milliseconds. Notice that this is the same timestamp that we created. And then so this is a week of data. I think I put this in there because Kafka, by default has a retention of seven days. So I wanted to bring all that in one query. Okay. So in this case, has, I guess that's 328,000 records already. Um, it's amazing that this is capturing it by hundreds there. Anyway, so this is what we have so far in a week. Let's see what we have in 1 minute. So nothing in the past. Let's do 5 minutes. So let's keep that original query, get all that history back. Okay. So now that we're doing that, you can see that some authors are updating a lot more than others. You'll find a lot of bots in here that's updating Wikipedia pages, and they tend to have the highest changes per minute. It's like 20s and 30 changes per minute. So you can always identify pretty easily what a bot is doing when it's updating changes in pages in Wikipedia. All right. So we've now done this whole path, Python to Kafka to Pinot. Now we're handling duplicate records in the RSS feed. Now let's see if we can take a look at it in the Jupyter notebook. Okay, I'm just going to kill this. The way we do that is just run Jupyter notebook. This will open up a page for you. This is the directory that we were working in, or I was working in. This is the Python or the Jupyter notebook here. Just click that. And you should have already in it the last run. So all you would need to do is just run each cell. So this cell, we're going to import the Pinot DB Python library. And then we're going to connect to Pinot. That'll create a connection. Okay. And then we're going to get a cursor to it. Now we can, let me see if I can change this to this query. I don't want to limit it to 10. Actually, maybe I should, but it doesn't matter. Okay, so let's run that. So all it's doing is printing out this data frame. So the thing to look at is this, the way we're converting using pandas. We take that cursor that gets executed the statement, and we're building columns from the description from the cursor, and then that's our data frame. Okay, and then we're kind of printing out our Python's toString of the table into Jupyter Notebook. So let's visualize this data. Okay, this visualization down here is an old one, so let's rerun this one. So what we're doing here is we've decorated the data frame to add a plot and a bar. The H here, this is a bar chart with the H meaning horizontal, and you're telling it to grab the authors and the changes from the data frame, and that's your histogram. And I'm inverting the y-axis, otherwise it'll be upside down. So I want the top, the highest messages or page changes out of all of them. As you can see, this guy's over 400 pages in the past week. But how can we do this while it's continually updating? As you know, Pinot is perfect for that. It's basically your query engine for Apache Kafka. Apache Kafka doesn't have a query engine. You could run a bunch of stream processors on top of it, but you can't throw an analytical query on a stream processor. It needs columnar storage. It needs the really powerful indexes to optimize and prune the data set so that it's only grabbing certain values. You need a very fast but low latency, high QPS system OLAP system, just like Apache Pinot, to generate this kind of to do this kind of task. So we're going to change this a little bit. We're going to define functions, and then we're going to add a thread, right? So this thread is going to update in the background this this uh this graph, right? And it's updating it every in this case 5 seconds. Let's see what happened here. Interesting. This is the same Instagram clear, pause, threading, timer, build, refresh value, the default value. Oh, this was working about 10 minutes ago. The demo gods are not happy with me today. Let me see, plot data. So this works. Convert access, that's this one. Let's not do the build. Let's not do this part just for now. Let's test that. So this should not do anything here. Okay, so build. Something odd with this one. Let me just define this. Let me build it down here. Oh, I could I assure you I'll double check the repository to make sure that it's working. And I'll get it to work before the end of the night. But basically, what will happen is you go to this Wikipedia chart, you'll see this update every 5 seconds. Okay, so you could set that 5 seconds. You could call a different 10 seconds or 2 seconds, and then it'll update that page, that record, that data set, that view for you every time. Okay. Um, you could by the end of the night, I'll have this working. So make sure if you're interested in doing this, to clone this repository and run it locally for yourself. I would probably recommend doing it tomorrow. Give me some time to finish it, but yeah, if you have any questions, I'm open to answering them right now.
Could you explain a little bit this upsert logic from Pinot side? Yes, because this is like, let me see, it's updating indexes when you're saying upsert is doing like full update, or this is just data update and we have the indexes update, or this is upsert guarantees that everything will be updated at the same moment.
Yeah, so typically these systems like Apache Pinot, they are immutable, right?
Yes, it's like
Um,
append only. Yes, what my
right,
question? Yes, what means
that's right.
upserts physically? It's we know that this is from databases like, but this is should be append only style of
That's
upsert.
right.
It's like
That's right.
version replacing. You're pretty much replacing latest version replace the previous version.
That's right. So we're not doing an actual upsert. It's just
Uh-huh.
understanding. In fact, one of our really uh committers of or contributors to Apache Pinot has a lot to do with this upsert logic. But basically, what it is that it's it's appending those records, that history. But when you query it, you're only getting the latest record, right? Does that make sense?
Yeah, you're doing like merge pretty much. You're merging and
Actually,
What's going on behind the scenes? Hey, Hubert, this is Robert.
Hey, Robert, how's it going?
Doing good. So, what's going on behind the scenes is that Pinot is keeping track of the latest version, has like a hash table behind the scenes that it's updating, kind of in memory. Whenever a record comes in with the same primary key, it's basically updating like a pointer to the latest version.
Mhm.
So those previous versions are still there, available for query for however long you want. Um, but yeah, when you do a query with Upsert enabled, um, you will get only the latest records back. You can also turn off kind of that query and get the that query option to get the full history if you'd like, because it's still stored internally. Pinot, like we said, is it's append only.
Okay, it's clear. It's most cases you have like a little bit eventual consistency. Yes, I can see one data, one data is it's still coming, it's in updating, but I still can get my old version. Yes.
Yeah, you can
Yeah,
get
you
full history depends on
Mhm.
how long you want to keep that old version. You can keep it
Okay.
indefinitely or clean it up
Mhm.
uh,
yeah.
if you only want to
And
maintain.
maybe just quick question, and maybe my last question. What happens because you're updating by primary key? Kafka is a system when you see some late arriving data. Yes. You mean some data is going too late, yes, and this can be very messy situations that by primary key my late data can kill my latest data, yes. How is this handled in these situations?
Will ignore any late arriving data. It'll only update like that pointer if the timestamp has advanced.
Okay, so it means you're tracking the timestamp, and this is timestamp, or this is a Kafka creation time, or you can specify the time from payload.
Yes.
Yeah. So we specified in the schema what the timestamp is, right?
Okay.
And then that's
Okay,
the
it's okay. It's and at this time it's coming from payload, but the same, which is you set up, let's say for Pinot segment, whatever. I don't know what the definition is for Pinot timeline. Yes, it's the same. Okay,
yes.
okay, thank you.
I have a question, Hubert.
Yeah.
Um, I see there's an example where you're using the multi-stage query engine.
Yes. Let's take a
Um,
look at that. Let's do that. I forgot about that one. Thanks for reminding me. So let's go to actually Pinot, or actually go to the Wikipedia. So this is a different type of query that is now supported in Apache Pinot 1.0. It's a window function. If you notice over partition, we're counting the titles and then adding this is a new column here we're going to add over the author, right? So let's run that really quickly in the Apache Pinot. Oops. What it will tell you is that is you need to use a multi-stage join ancient, so you have to click that box above this one. Make sure my Pinot is running. Here we are. So let me make sure I stop my producer because I have over 2.5 million records now. I need to clean this up before we run out of space. um, so I'm running everything locally. So yeah, this is a window, right? So right now it's doing a by title. So this bot here is changing a lot of records in a lot of users in the past week. Let me just I don't have a timestamp filter here. So yeah, so what I think the issue here is that I have way too much data. Oops. And I need to change my table config to only read not from the earliest, but maybe from just the latest records. This is getting probably a week's worth of data that I've been sending. Notice that it's been creating partitions or segments along the way, right? It's been creating a lot of them. So you click any one of these, you can get the status of each segment. And it's creating segments based on the timestamp. Yeah, thanks for reminding me that, Robert. There are also join options. It's not really the focus of this meetup, but joins is a huge contribution to the Pinot project, and definitely go ahead play with a lot of these examples here. You'll be able to do you'll see you'll be able to do a lot of complex um, aggregations and analytical um, lookups for your application. Right. This is a good segue because the next meetup will be based on joins. Um, Specifically, we're going to talk about Apache Flink and demonstrate how to integrate that with Apache Pinot and when to do joins. Do I do my joins in Apache Flink or do I do them in um, Apache Pinot? And how that relates to the idea of one big table or OBT, right? One big table is just a really big denormalized table. Um, and the idea is there is to make have really fast queries, but then at the cost of like maybe redundancy and storage, right? Um, and what does that mean when you do upserts, right? Do you still need to do upserts? What advantages or disadvantages do you get with one big table, right? You do get some advantages by joining at a pull query or the analytical at Pinot. Um, but then what kind of things do you lose by doing so? So those are some of the things we'll cover in the next meetup. I believe it's in January, mid-January somewhere. All right, guys. Check back on the repository. It'll be working by tomorrow. I apologize for that. Any other questions? Oh wait, here we go.
Just gonna say thanks, Hubert. This was very interesting and helpful.
Thank you, Steve. Wow, I haven't talked to you in a while. Didn't realize you signed up for the session. So welcome. Thanks for being
I'll be attending two of them coming up here. I'm
awesome.
I'm getting back off my diversion and back to Pinot. So
That's good to hear. Next year is going to be a good one for Apache Pinot. There are lots of exciting things to talk about. Really, really a good time to get started up again with Pinot.
awesome.
All right, guys. I'm going to end this. If you have any questions, you can find me on the community Slack or in LinkedIn. Just hit me up. All right. Any last questions, Robert? Again, thank you for the backup there. Appreciate that.
You're welcome. Bib, who has a question, I think,
Yes.
regarding Upsert.
Thanks. These are probably updated records. So how does it impact the query performance? Um, I don't think I understand the question. Is there a possibility of the updated records for low rounding?
So my question was, I think Robert, thank you for answering the previous one. So what I understood is like the way Upsort works is you have multiple entries for the same row, and you are fetching the latest row based on the timestamp and based on the primary keys, right? So so my first concern was like, is there a possibility where the storage will blow up? Because say, for example, if you have a file where every single record is updated, that means it is doubling the storage effectively. And Robert said that
Yes.
you have compaction. Now,
Yeah.
now when you're compacting data, you are probably compacting into multiple segments. Is there a possibility that the updated rows for the same, or how do I put it? So the updates for the same row end up in multiple segments. Thereby, when you are querying, the query has to scan multiple segments to get the latest one.
So yeah, after compaction, there will only be one latest version,
I see. Okay. Got
right?
it. Got it. Got it.
In,
Okay.
it's kind of like the new version of that segment. So when compaction works, it'll basically just rebuild that segment, create a new version of that segment that only has like the latest versions in it.
I see. I see.
Unless there's
Okay.
nothing, unless it's like completely old, it'll just delete the segment
Uh-huh.
altogether. But you still end up with having multiple segments after compaction.
Mhm.
If like your records are spread across multiple segments, then yes, query performance then kind of suffers a little bit. Compaction doesn't yet handle merging segments together.
Okay. Okay. Got it. Got it.
Yeah.
So thank you for explaining.
Yeah. By the way, Robert is the author of that compaction feature. So thank you.
Yeah, awesome. Thanks.
Thanks, Hubert.
Yeah. Thanks, guys. Have a good
Thank you,
one.
folks.
Yeah. Till next time.